Voyager 1 is 24 billion kilometers from Earth right now. It is the furthest thing humanity has ever built, hurtling through the void 14 times faster than a bullet. And it is dying. I need you to stay with me tonight because what I'm about to tell you isn't just the story of a spacecraft running out of power. This is the story of the most ambitious message in a bottle ever created, a golden record spinning through infinite darkness, carrying everything we are to someone we will never meet. And the clock is ticking. You've heard about Mars missions. You've seen the headlines about SpaceX and lunar bases and colonies on other worlds. But here's what no one is telling you. While we argue about whether humans can survive on Mars, the furthest object we've ever launched is about to go silent forever. Not temporarily, not fixably, forever. And when it does, it will drift alone through the cosmos for billions of years, carrying a message from a species that may no longer exist. Let me tell you why that should shake you to your core. Voyager 1 launched on September 5th, 1977. Think about that for a moment. 1977. Jimmy Carter was president. Star Wars had just hit theaters. The internet didn't exist. And NASA strapped a spacecraft to a rocket and flung it toward the outer planets with less computing power than the phone sitting in your pocket right now. That spacecraft is still out there, still moving, still whispering back to us across the darkness. But let me put the distance into perspective because we throw around numbers like 24 billion kilometers and our brains just glaze over. We nod and move on. So let me make you feel it. The distance from Earth to the Sun is about 150 million kilometers. That's what scientists call one astronomical unit. Voyager 1 is currently 163 of those units away from us. That's more than 4 times the distance from the Sun to Pluto. If you got in your car right now and drove at highway speed toward Voyager, it would take you over 30 million years to reach it. And Voyager isn't waiting for you. It's moving away at 61,000 kilometers per hour. Here's the part that really gets me. When NASA sends a radio signal to Voyager 1, that signal travels at the speed of light, the fastest speed anything in the universe can travel. And it still takes 22 hours and 36 minutes to arrive, then another 22 hours and 36 minutes for the response to come back. A simple conversation takes nearly 2 full days. 1 question, 1 answer, 2 days. And yet somehow, NASA engineers are still talking to this spacecraft, still sending commands, still receiving data. Let me say that again because it deserves to sink in. Scientists on Earth are actively communicating with a machine that is 24 billion kilometers away, launched nearly 50 years ago, using a transmitter with the power of a 20-watt light bulb. That's about as strong as the bulb inside your refrigerator. That tiny whisper crosses billions of kilometers of empty space, and massive 70-meter radio dishes here on Earth capture it. That is one of the most extraordinary engineering achievements in human history, and most people have no idea it's happening every single day. Stay with me here because this is where the story takes a turn that changes everything. Last November, Voyager 1 went silent. Not the poetic kind of silent, the terrifying kind. It started sending back random strings of data, gibberish, noise. After 47 years of faithful service, the furthest human-made object in existence started speaking in tongues. Now, of course, conspiracy theorists had a field day. Aliens captured Voyager. Extraterrestrials were using it to send coded messages back to Earth. The truth, as it usually is, was far more mundane, but in many ways more impressive. Engineers identified a problem with the flight data subsystem. They wrote new code. They transmitted that code across 24 billion kilometers of space. They waited nearly 2 days for the response. And Voyager 1 came back to life. They saved a spacecraft older than most of the people reading about it, remotely from Earth. If that doesn't give you chills, I don't know what will. But here's what most people miss. That rescue didn't fix the real problem. Voyager 1 survived that crisis. It won't survive the next one, because Voyager isn't dying from a software glitch. It's dying from something no engineer can fix. Voyager 1 is powered by 3 radioisotope thermoelectric generators. These are essentially nuclear batteries that convert heat from decaying plutonium into electricity. And plutonium decays. That's what it does. You can't refuel it. You can't recharge it. You can't send a replacement battery across 24 billion kilometers of space. The power is draining, and it has been draining since the day Voyager launched. NASA has been making impossible choices for years now, turning off heaters, shutting down redundant instruments, sacrificing one system to keep another alive just a little longer. They even turned off the camera, the same camera that took the most iconic photograph in human history. They turned it off to save power for the instruments that are still doing science. And sometime in the next few years, there won't be enough power left to run anything at all. The last instrument will go dark. The last signal will be sent, and then silence. Permanent, irreversible silence. Voyager 1 will become a ghost ship, drifting through interstellar space with no way to call home and no one listening, even if it could. Now, I need to tell you why. What happens after that silence is the most profound part of this entire story. Subscribe right now and turn on notifications, because what comes next is the reason I made this video, and it's something I think about constantly. When Voyager goes dark, its mission doesn't end, not even close. The journey is just beginning. Over the next 300 years, Voyager will coast toward the Oort cloud, a vast sphere of icy debris surrounding our solar system. It will take 30,000 years just to pass through it. 30,000 years. For context, 30,000 years ago, humans were painting on cave walls and hadn't invented agriculture yet. That's how long it takes to cross our own cosmic backyard. And after that, Voyager enters true interstellar space. It will orbit the Milky Way galaxy every 225 million years, the same lazy orbit our sun takes, occasionally drifting past neighboring star systems, a tiny metal ambassador from a tiny blue world. Here's where it gets genuinely humbling. Voyager 1 will likely outlast everything we've ever built, every building, every bridge, every monument, every city, long after the pyramids have crumbled to dust, long after every trace of human civilization on Earth has been erased by time. Voyager will still be out there, intact, drifting, carrying us with it, and it won't be empty-handed. Let me connect some dots here, because this is the part that keeps me up at night. Before Voyager launched, a team led by Carl Sagan created something called the Golden Record. It's a 12-inch gold-plated disc attached to the side of the spacecraft, and it contains everything someone would need to understand who we are. Images of Earth, images of humans, mathematical and scientific information, greetings in 55 different languages, the sounds of wind and rain and birds and whales, music from Bach to Chuck Berry, a mother's first words to her newborn child. They included a map, not a rough sketch, a precise pulsar map that pinpoints the location of our sun relative to 14 pulsars in the galaxy. If anyone finds Voyager, they won't just know we existed. They'll know exactly where to find us, or where to find whatever is left of us. Think about what that means. We took the best of ourselves, the music and the science and the sounds of our world, and we flung it into the darkness on the chance, the impossibly small chance, that someone might find it. Not in our lifetime, not in our children's lifetime, maybe not for millions or billions of years. We sent a message we will never see delivered to a recipient who may not exist. I need to address something that people always bring up at this point. They say, won't space destroy it? Won't radiation or micrometeoroids or the vacuum itself tear Voyager apart over billions of years? Here's the truth. Space is remarkably gentle to objects drifting through it. There's no weather, no oxygen to cause rust, no erosion. The biggest threat is micrometeoroid impacts, but space is so incomprehensibly empty that the odds of a significant collision are vanishingly small. Voyager's golden record could remain readable for over 1 billion years. Let me say that again, 1 billion years. Our message could outlast our sun. But here's the devastating counterpoint. Space is so vast, so absurdly, incomprehensibly enormous, that the chances of anyone actually finding Voyager are almost zero. It's not a needle in a haystack. It's a needle in 1 billion haystacks scattered across a continent the size of a galaxy. Voyager will pass within 1.6 light years of a star in about 40,000 years. That's the closest it will come to anything for a very long time. And 1.6 light years is still about 15 trillion kilometers. That's not close, that's cosmically adjacent, which in practical terms means impossibly far. So we built a message that could last forever, and we sent it into a void so vast that forever might not be long enough for anyone to find it. If that isn't the most human thing we've ever done, I don't know what is. If this is hitting you the way it's hitting me, do me a favor, hit that like button right now and drop a comment telling me where you're watching from tonight. I want to see how far this video reaches, because the idea of messages crossing vast distances feels especially appropriate right now. Now let me take you back to February 14th, 1990, Valentine's Day. Voyager 1 was 6.4 billion kilometers away and leaving our solar system for good. And a man named Carl Sagan had been campaigning, practically begging NASA to do something that everyone said was pointless. Turn the camera around. Take one last picture of Earth. The scientists pushed back. There's no scientific value, they said. It's a waste of precious energy. But Sagan insisted, and NASA, to their eternal credit, agreed. What they got back was a photograph that changed how humanity sees itself. A single pixel, less than a single pixel. Earth appeared as a tiny pale blue speck, caught in a scattered beam of sunlight, floating in the blackness of space. The pale blue dot. Sagan wrote about that image, and his words are some of the most powerful ever committed to paper. He described that dot as everything we've ever known. Every king and peasant, every war and every peace, every act of love and every act of cruelty, all on a mote of dust suspended in a sunbeam. The camera that took that picture is now off, permanently, shut down to conserve power. But I wondered, what if we could turn it on one more time? What would Voyager see now from 24 billion kilometers away? I ran simulations, and the answer is both beautiful and devastating. The sun would appear as a faint, blurry dot of light. The planets would be barely visible smudges around it. Our entire solar system, everything we have ever known or explored or dreamed about, reduced to a tiny smear of light that you could cover with your thumbnail. That is our cosmic neighborhood. That faint glow contains every human who has ever lived, every story ever told, every song ever sung. And because the universe is simply too vast, because the distances between stars are too great and the laws of physics too unforgiving, this is probably all humanity will ever know. This is home, not just for now, potentially forever. Here's where it gets genuinely beautiful if you let it. The same physics that traps us here, the speed of light limit, the vast distances, the energy requirements that make interstellar travel essentially impossible for biological beings, those same laws are what made us possible in the first place. The universe had to be this big and this old for the elements in your body to be forged in dying stars, scattered across space, and reassembled into something that could look up and wonder why. We are not a species that failed to conquer the cosmos. We are a species that the cosmos created to understand itself. And we sent a golden record into the darkness to prove it. When Voyager finally goes quiet, and it will probably within the next few years, it will not be a tragedy. It will be a graduation. Voyager completed every mission we gave it and then kept going. It showed us Jupiter's storms and Saturn's rings. It taught us where our solar system ends and interstellar space begins. It gave us the pale blue dot, and then it carried our music and our voices and our hopes into the infinite dark, asking nothing in return. The spacecraft will drift for billions of years. Our sun will exhaust its fuel and swell into a red giant, consuming Mercury and Venus and possibly Earth. The Milky Way will collide with the Andromeda Galaxy in about 4.5 billion years. Stars will be born and die and be born again. And through all of it, Voyager will still be out there, carrying a golden record that says we were here, we were small, we were brief, but we were magnificent. Let me leave you with 3 things tonight. First, Voyager 1 is the single greatest distance any human creation has ever traveled, and it is about to go silent forever. There is no rescue mission. There is no replacement. When it goes dark, humanity's furthest outpost goes dark with it. Second, the golden record it carries may outlast every other trace of human civilization by billions of years. It is, in a very real sense, our most permanent achievement, not our buildings or our cities or our digital archives. A gold-plated record strapped to the side of a spacecraft the size of a small car. Third, and this is the one I want you to carry with you, we didn't send Voyager because we expected an answer. We sent it because we are the kind of species that sends messages into the void hoping someone is listening. That impulse, that irrational, beautiful, deeply human impulse is worth more than any response could ever be. Now, if you thought this was mind-blowing, you're not ready for what's in the next video. It's on your screen right now. Click it before you forget. I'll see you there.